Welcome everyone. It's a pleasure to welcome you to this poster presentation. Today, we explore and share the following ideas regarding a proposal for glucose biosensing. Beginning with the introduction, magnetic iron nanoparticles offer an attractive possibilities in biomedical application, which can be modified with various compound agents to covalently bind specific bioligands to magnetic nanoparticle surfaces. In previous reports, amine and carboxyl groups, functionalized silica-coated magnetic particles were used to covalently immobilize enzymes and possibly quantify the protein that promotes catalytic activity in it. With the specific coupling agents, we can immobilize an enzyme named glucose oxidase. This enzyme catalyzes the oxidation of glucose, converting it into gluconic acid, which ionizes in an aqueous medium. But previously of the immobilization, we synthesized these nanoparticles with specific chemical groups that generate functionalized surface capable of anchoring intermediary groups as EDC and NHS. The method of synthesized nanoparticles follow this sequence. Then, the magnetic nanoparticles were characterized using high-resolution microscopy techniques, such as scanning and transmission electron microscopy. The magnetic nanoparticles are nearly spherical in shape, with an average size of 18.2 nanometers, as you can see in this image. The microscopy, named with the letter C, we can observe the silica coated magnetite, and we can see two regions with different electrode densities. We can be distinguished an electric dense core, presumably corresponding to magnetite, and the less dense layer region surrounding the core, likely the silica core. The indirect quantification of iron, oxygen, and silicon content in each sample was obtained through energy dispersed X-ray spectroscopy (EDS) analysis, yielding significant values of these three elements. In the figure, named with the letter E, we can observe the electron diffraction patterns were obtained, and we can check the lattice parameters when we use to identify reflection corresponding to magnetic phases and characteristic silicon oxide phases. Then, we traduce the signal generated by the glucose oxidation reaction with the design of ion-sensitive field effect transistor Isfets device that it is built on a flexi PET substrate coated with a ethos field. One of them has a channel dividing the substrate into two regions, which were used as source-drain contacts. A solution of semiconductor P3HT was deposited on a channel using the drop casting technique, forming a thin film. Another PET ethos substrate serving as a gate, and it was divided in half and had the electric material, PDMS, deposited using the doctor plate technique. A second graphene contact, as the yellow image, was made of laser-induced graphene that is porous and serves as an immobilization surface where the silica core shell magnetic nanoparticles with functionalized groups, which will bind to glucose oxidase enzyme. Then, the Isfets were characterized by connecting them to source meter models. Applying a source drain from 0 to 3 volts, and the source drain voltage is kept fixed at 1 volt. This generates a current curves for each concentration of glucose in aqueous solution. In the graph in the lower corner, we can visualize the current voltage curves for each glucose concentration. The y-axis represents the current measured from the source drain contacts, and the x-axis represents the voltage induced on the source drain contacts. The image called B in the lower right corner describes the insertion procedure of the inorganic and biological species to deposit on the graphene, which serves as the contact to the transistor. It's evident that as the glucose concentration value increases, the current value also increases, indicating as a proportional relationship between two variables. As these are standard solutions, they can allow us to predict the behavior of Isfets regarding to the transduction of detected ions in the immobilization surface. I thank all of you for your interest and participation. Without further ado, I invite you to explore this poster, interact with the authors, and ask questions and promote enriching discussions. If you have any question, please contact us to this mail. Thank you.